In this video, we will be discussing the top 25 Cypress interview questions and answers. This is a comprehensive guide designed to prepare you for any Cypress-related interview. From understanding the fundamentals to discussing complex scenarios, this video will help you confidently handle Cypress-related queries during your interview. Tune in to enhance your knowledge and stand out in your next interview. 1. What is Cypress? Cypress is a next-generation front-end testing tool built for the modern web. Unlike traditional testing tools, Cypress provides a simple, intuitive, and user-friendly platform for developers to write automated tests for their web applications. It is built on a new architecture and runs directly in the browser, which enables it to provide reliable, fast, and consistent tests. It is primarily used for end-to-end, E2E, integration, and unit testing. It is open source and can be used for testing anything that runs in a browser. Cypress is a very powerful tool for testing web applications. It is built specifically for developers and QA engineers to help them get more done. Cypress benefits from a rich ecosystem of support, including a dedicated team of developers working to continuously improve the tool. It brings a modern, fast, and reliable testing solution to the JavaScript and web development community. It supports real-time reloading and automatic waiting, thus eliminating the need to add waits and sleeps to your tests. This results in faster and more reliable tests. 2. How does Cypress differ from other testing frameworks like Selenium? Cypress is fundamentally different from Selenium, from its architecture to the capabilities it offers. Unlike Selenium, which operates by running outside the browser and executes remote commands across the network, Cypress runs directly in the browser. This enables consistent, reliable tests that are faster because they run as part of your application. Cypress also provides better error handling in debugging. With real-time reloading, time travel debugging, automatic waiting, and more, it's easier to write and debug tests using Cypress. Another key difference is how they handle asynchronous operations. While Selenium requires explicit waits and sleep commands, Cypress automatically waits for DOM elements to appear, disappear, or meet certain conditions. In response to these differences, Cypress provides a more efficient, reliable, and developer-friendly environment for end-to-end testing. By running directly in the browser and handling synchronization issues, Cypress minimizes flaky tests and speeds up test execution. Its rich and interactive UI also makes it easier to understand what's happening during test execution, making debugging quicker and simpler. However, it's important to note that Cypress supports only JavaScript, while Selenium supports multiple programming languages. This can be a limiting factor if your team uses a different programming language. Also, Cypress currently supports only Chrome-based browsers, while Selenium supports multiple browsers. Despite these limitations, many teams find that the benefits of Cypress outweigh its drawbacks, especially for testing modern JavaScript frameworks. 3. What are the advantages of using Cypress for testing? Cypress offers several benefits for testing. Firstly, it provides real-time feedback. As soon as you save your test, it runs automatically, providing instant results. This feature enhances productivity as you can quickly identify and fix issues. Secondly, Cypress has automatic waiting, meaning you don't need to add waits or sleeps to your tests. It intelligently waits for elements to become actionable before performing actions on them. This feature can significantly reduce flakiness in tests. Thirdly, it simplifies handling asynchronous operations. Traditional testing frameworks often struggle with asynchronous nature of JavaScript, but Cypress manages it effectively. It also supports end-to-end testing, integration testing, and unit testing, making it a versatile tool. Lastly, it has excellent documentation and an active community, which can be a great help for developers. Cypress also has a unique architecture that runs directly in the browser, which allows it to control every aspect of the automation process, from network traffic to executing your test code. This results in more consistent results and faster test execution. It also has built-in screenshot and video recording, which can be incredibly useful for debugging and sharing test results with your team. Cypress is built on JavaScript, which is currently the most popular programming language. This means that there's a good chance your team already knows JavaScript, making it easier to get started with Cypress. Additionally, because Cypress tests are written in JavaScript, you can use all the features of the language and its ecosystem. 4. What programming language is primarily used in Cypress? The primary programming language used in Cypress is JavaScript. It's a powerful language that is widely used in web development, making it a natural choice for a web testing framework like Cypress. JavaScript is used to write the tests that will be run by Cypress, and it's also the language that Cypress itself is written in. This means that if you're familiar with JavaScript, you'll feel right at home using Cypress. Cypress is primarily built on JavaScript. It is the main language used for writing tests. JavaScript's dynamic and flexible nature makes it an excellent choice for handling various testing scenarios. The Cypress framework itself is also built using JavaScript. This makes it easier for those with JavaScript knowledge to quickly grasp the Cypress testing framework. One of the reasons that JavaScript was chosen is because it's the most commonly used language in web development. This makes it easier for developers to adopt Cypress into their workflow. 5. Can you describe the architecture of Cypress? Cypress is built on a unique architecture designed to be fast, reliable, and more efficient than other testing tools. The architecture operates directly in the browser, eliminating network lag or remote commands that can slow tests down. It works synchronously and in real time, so tests run as soon as the code changes. Cypress is built on top of Mocha, which is a feature-rich JavaScript test framework. This allows for a familiar syntax and structure for developers who have worked with Mocha, but with the added benefits of Cypress's unique architecture. Unlike Selenium, which runs remotely outside the browser, Cypress runs directly in the browser. This allows for real-time reloading and faster test runs. The architecture of Cypress also allows for automatic waiting. This means that you don't have to add waits or sleeps to your tests, as Cypress will automatically wait for commands and assertions before moving on. In addition, Cypress has full access to every object in your application. This includes the window, the document, a network traffic, or any other object you would have access to in your browser's developer tools. This is a powerful feature that allows for more complex and thorough testing. Cypress's architecture is designed to handle modern JavaScript frameworks especially well. Whether you're using React, Angular, Vue, or something else, Cypress has you covered. 6. How do you install Cypress in a project? To install Cypress in your project, you primarily need to have Node.js installed in your system. Once this is established, navigate to your project directory using your command line interface and input the command npm install cypress save dev. This installs Cypress as a dev dependency in your project. After the installation process completes, you can verify the installation by running /node_modules/.bin cypress open. This command opens the Cypress test runner, which confirms that the installation was successful. This entire process is quite simple and straightforward, allowing you to quickly incorporate Cypress into your project for robust testing. Remember, it is critical to install Cypress in the project directory and not globally. This ensures that all team members working on the project use the same version of Cypress, ensuring consistency and avoiding potential issues. 7. What types of testing can be performed using Cypress? Cypress is a versatile testing tool that supports a variety of testing types. These include 1. End-to-end testing. Cypress is well known for its ability to perform end-to-end testing. This involves testing a complete workflow from start to finish. 2. Integration testing. Cypress also supports integration testing. This is where you test how different parts of your system work together. 3. Unit testing. Although it's not as common, you can use Cypress for unit testing too. This involves testing individual units of code to ensure they work as expected. 4. UI testing. Finally, Cypress is great for testing user interfaces. This involves checking that all elements on a page are rendered correctly and function as expected. Cypress can truly cover all bases when it comes to testing, making it an invaluable tool in any development project. Cypress is a robust tool that allows you to perform various types of testing. This includes end-to-end testing, where the entire application flow is checked from start to finish, ensuring all integrated parts are working together. It also supports integration testing, where individual units of your application are tested to see how they interact with each other. Even though it's not its primary function, it is possible to perform unit testing with Cypress, where each piece of code is tested individually. Furthermore, Cypress excels in UI testing, where the user interface is tested for functionality, ensuring that all elements are displayed and interact as they should. This versatility makes Cypress an invaluable tool for any development team. 8. What are fixtures in Cypress, and how are they used? Fixtures in Cypress are used to manage the data that your test will manipulate. Instead of having to create and tear down your database or other data stores, you can use fixtures to load data that your tests need to run. Fixtures are typically used as a means to load a fixed set of data located in a file. In Cypress, fixtures are stored in the fixtures folder by default. You can specify a different folder in your configuration. You can use the fixture function to read a file and make its contents available for your tests. The data can then be used to fill out forms, validate responses, or simulate server responses. Fixture example. JSON, then, data, equals greater than. Now do something with data. Closing curly bracket closing parenthesis. In the above example, the example JSON file will be loaded and the content will be assigned to the data variable. This functionality is particularly useful when you want to create robust, repeatable tests. 9. How do you handle asynchronous operations in Cypress tests? Cypress has been designed to automatically manage asynchronous operations. It uses a different approach from traditional testing tools which rely on callbacks, promises, or async, a way to handle asynchrony. With Cypress, you don't need to wait for elements to become available or actions to finish. Interacting with elements in the DOM is done synchronously, but under the hood, Cypress retries commands and assertions until they pass or time out. In Cypress, you can use then method to handle asynchronous actions. For instance, when you want to work with the data from XHR requests, you can use request, which returns a promise and allows you to interact with the response data. If there's a delay in an element being available, Cypress automatically waits for it before proceeding, thus effectively handling asynchronous behavior. Commands in Cypress are enqueued and run in a sequence, ensuring that they're executed in the order written. This feature of Cypress removes the complexities that come with writing asynchronous code, making your tests easier to write and understand. 10. What is the purpose of the visit command? The visit command is used in Cypress to navigate to a specified URL as part of a test. It acts like a user manually typing a URL into the browser and hitting enter. This command is typically one of the first commands called in a test, ensuring that the test starts from the correct web page. It's important to note that visit can only navigate to the same origin, the same superdomain, port, and protocol as your test due to Cypress's security restrictions. This command also waits for the page to load, the load event to be fired, and all the scripts to be downloaded and evaluated before moving on to the next command. The visit command serves a fundamental role in Cypress tests. This command is responsible for directing the browser to a specified URL during the execution of a test. It's akin to a user manually inputting a URL into their browser and pressing enter. Typically, this command would be one of the initial commands invoked in a test to ensure that the test commences from the intended web page. However, due to security restrictions in Cypress, the visit command can only navigate to the same domain as your test. This means your test and the URL you're attempting to navigate to must share the same superdomain, port, and protocol. Another key feature of the visit command is its built-in waiting mechanism. When this command is executed, it waits for the page to fully load, for the load event to be fired, and for all associated scripts to be completely downloaded and evaluated before proceeding to the next command in the test. This ensures that the test doesn't proceed until the necessary conditions have been met. 11. How can you perform API testing using Cypress? Cypress is a versatile testing tool that can also be used for API testing. To conduct API testing, Cypress provides commands such as request, its, and should. The request command is used to make HTTP requests. This can include POST, GET, PUT, delete, etc. Once the request is sent, the server's response can be asserted using its and should. For example, to test if a GET request to a specific URL returns a status code of 200, you can use request URL.its status should EQ 200. Cypress also allows you to stub responses, thus enabling you to test how your application handles various scenarios. This is particularly useful as it allows testing under controlled conditions, without having to rely on the actual server response. Cypress is a powerful tool for API testing, providing a suite of commands specifically designed for this purpose. The command request can be used to make HTTP requests, including GET, POST, PUT, and delete. The response from these requests can be tested using the its and should commands. For instance, you may want to ensure a GET request to a specific URL returns a status code of 200. The code would look something like this. request URL dot its status should EQ 200. In addition, Cypress also allows for the stubbing of responses. This means that you can simulate different responses from the server, allowing for more controlled and reliable testing conditions. 12. What are custom commands in Cypress, and how do you create them? Custom commands in Cypress are beneficial for simplifying test cases by encapsulating repetitive test steps into a single, reusable function. These commands augment the built-in commands that come with Cypress, enabling you to create a more efficient and maintainable test suite. To create a custom command, you need to add a new function in the commands.js file located in the Cypress support directory. Here is a basic example. Cypress commands.add login username password equals greater than cy.get input name equals username type username cy.get input name equals password type password cy.get button type equals submit click closing curly bracket closing parenthesis. In your test cases, you can use this custom login command like any other Cypress command. Login test user password 123 feet. Remember, the name of the custom command should be unique, not conflicting with any existing Cypress commands. Custom commands are a nifty feature in Cypress that can significantly enhance the efficiency and readability of your test scripts. They help minimize redundancy by encapsulating repetitive sequences of commands into a singular, reusable function. Creating them is a straightforward process. You need to define a new function in the commands.js file, which you can find in the Cypress support directory. This function should encapsulate the sequence of commands you frequently use. For instance, if you frequently need to log into a system during your tests, you can create a login command. This command would include the steps to input the username and password, followed by clicking the submit button. Once created, you can call this login command in your tests like any other built-in command. It's a good practice to choose a unique name for your custom command to avoid clashes with existing commands. 13. Can you explain what Page Object Model, POM, is in Cypress? Page Object Model, POM, is a popular design pattern in test automation. POM's concept revolves around creating an object repository for web UI elements. In the context of Cypress, we use POM to represent web pages or components as JavaScript objects. Each object has properties and methods that correspond to UI elements and their interactions. This way, we have a single place to maintain our selectors and methods, making our tests more maintainable and less brittle. It helps us keep the code clean and readable, and it makes tests easier to update if the UI changes. 14. How does Cypress handle timeouts, and what is the default timeout value? Cypress has a built-in mechanism to handle timeouts, which is beneficial for end-to-end testing. It ensures that tests do not fail due to delays in loading or asynchronous operations. Cypress waits until elements are available or actions are completed before proceeding to the next command. This behavior is controlled by various timeout values set in the configuration. The default command timeout is 4000 milliseconds, which means Cypress will wait up to 4 seconds for a command to complete before it throws an error. This timeout value can be customized to suit your testing needs. Cypress also provides the wait function to pause the execution of commands for a specific amount of time. This is particularly useful when you need to wait for a certain condition to be met before continuing with your tests. Cypress handles timeouts intelligently. In contrast to other testing tools that require you to manually set wait times, Cypress automatically waits for commands and assertions to pass. It understands the asynchronous nature of web apps and accommodates for it. By default, the timeout value is 4000 milliseconds for most commands. This means that Cypress will wait up to 4 seconds for an element to become available or an action to complete. If those conditions are not met within the timeout period, the test will fail. However, it's important to note that this value can be modified according to the needs of the test. 15. What is the role of before each in a Cypress test suite? The before each function plays a crucial role in the Cypress test suite. It serves as a setup block for each test case within a particular test suite. This function gets executed before every single test run inside the suite. This is especially useful when you have to perform some repetitive tasks before each test case, like visiting a web page, logging into an account, or resetting the database. It helps to keep your test cases dry, don't repeat yourself, simplifies the test structure, and makes the tests easier to maintain and understand. For example, if you have a test suite where each test requires a user to be logged in, you can use before each to log the user in before each test rather than repeating the login code in every test case. Describe test suite equals greater than before each equals greater than login username password hypothetical login command closing curly bracket closing parenthesis semicolon test case 1 foot equals greater than test code goes here closing curly bracket closing parenthesis semicolon test case 2 feet equals greater than test code goes here closing curly bracket closing parenthesis semicolon closing curly bracket closing parenthesis semicolon. In this example, the before each function will run the login command before each test case, ensuring the user is always logged in when the tests run. 16. How do you debug tests in Cypress? Debugging tests in Cypress can be done in several ways. One approach is to use the debug command, which allows you to pause execution of a test and inspect the state of your application at any point. This command can be chained to any other command, stopping before the following command is executed. Another technique is to use the pause command, which halts test execution and gives you the ability to step through your commands one by one, inspecting the state of your application as you go. You can also employ the sci.log command to display messages in the test runner's command log. The Cypress test runner itself is another powerful tool. It provides a visual representation of your tests and commands, allows you to see exactly what happened at each step, and even travel back in time to see what the DOM looked like. Lastly, the use of Chrome DevTools is also very beneficial. As Cypress runs directly in the browser, you can use Chrome's DevTools to inspect elements, view console output, network traffic, etc. Remember, good test design and understanding of the application under test can also significantly reduce debugging efforts. 17. What are some best practices for writing effective Cypress tests? Writing effective Cypress tests involves several best practices. First, you should aim to write small, focused tests. This makes them easier to understand and debug. Avoid using wait without a fixed time, as this can lead to flaky tests. Instead, use Cypress's inbuilt retriability to wait for elements or assertions. Use data asterisk attributes to select elements, as this reduces the likelihood of breaking tests when the UI changes. Make use of hooks like before each to set up preconditions for your tests, which can help reduce repetition. Lastly, structure your tests in a way that promotes readability and ease of maintenance. For instance, consider using the page object model, POM, to abstract away the details of UI interactions. Writing effective Cypress tests can be achieved by following these steps. Start by writing small, targeted tests that are easy to understand and debug. Avoid using wait without a fixed time to prevent the creation of unreliable tests. Instead, utilize the retriability feature in Cypress to wait for elements or assertions. Select elements using data asterisk attributes to reduce the chances of breaking tests when there are changes in the UI. Utilize hooks like before each to set up the conditions required for your tests, helping to decrease repetition. Finally, organize your tests in a way that enhances readability and eases maintenance. An example of this is using the page object model, POM, to simplify the details of UI interactions. 18. How can you capture screenshots or videos during test execution? Cypress provides built-in functionalities to capture screenshots and videos during test execution. To capture screenshots, you can use the screenshot command. This command can be used at any point in your test to capture a screenshot of the current state of your application. By default, Cypress also records a video for every spec file when running tests from the Cypress run. The videos are stored in the Cypress videos folder. If you want Cypress to automatically capture screenshots on test failure, you can set the screenshot on run failure option to true in your Cypress JSON configuration file. Cypress has built-in support for screenshots and videos during test execution. The command screenshot can be used to capture a screenshot at any point in your test. This is useful for debugging and understanding the state of your application at different points in time. On the other hand, when Cypress runs tests from the command line with Cypress run, it automatically records a video of the entire test run. This video is saved to the Cypress videos directory by default. Additionally, Cypress can be configured to automatically take a screenshot when a test fails. This is done by setting the screenshot on run failure option to true in the Cypress JSON configuration file. This helps in understanding the state of the application when the test failed. 19. What is the significance of sci.get? In your tests, sci.get is a Cypress command that is pivotal to your tests. It is primarily used to query and retrieve one or more DOM elements in your application under test. This command is very similar to jQuery's $.get method. It is widely used in Cypress tests to interact with the web elements, such as clicking a button, typing into a form, or checking if a particular element exists in the DOM. The sci.get command uses the CSS selector to find the elements. It also automatically retries itself until the element is found or until the command times out. This feature ensures that your tests do not fail due to elements not being immediately available due to various reasons like network latency or elements being rendered asynchronously. Sci.get is an essential command that plays a crucial role in Cypress tests. This command is primarily used to retrieve one or multiple DOM elements within your application that's under test. It functions similarly to jQuery's $.get. In Cypress tests, it's commonly used to interact with web elements such as typing into a form, clicking a button, or confirming the existence of a certain element in the DOM. The sci.get command uses CSS selectors to locate the required elements. It also automatically retries until it finds the element, or until the command times out. This means your tests won't fail because elements are not immediately available due to network latency or asynchronous rendering of elements. 20. Can you explain how to manage environment variables in Cypress? Environment variables in Cypress allow for dynamic configuration during test runs. These variables can be set in different ways, such as through the configuration file, Cypress, JSON, the command line, or within your test files. In the configuration file, you can add a env key and define your variables. For example, opening curly bracket, env, login_URL, http://localhost port 3000/login. Products_URL, http://localhost port 3000/products. Closing curly bracket. Closing curly bracket. You can access these variables in your tests using cypress.env, variable name. From the command line, you can use the env flag followed by your variables. For example, Cypress run env host equals Kevin, API_server equals http://localhost port 8888. In your tests, you can use cypress.env, variable name, new value, to change the value of a variable for the duration of the test's run. Remember, environment variables should not be used to store sensitive data, as they can be exposed in logs or reports. 21. How do you integrate Cypress with CI/CD pipelines? Cypress, a modern end-to-end testing framework, can easily be integrated into continuous integration and continuous delivery (CI/CD) pipelines. This integration is essential for automating the testing process as part of the software development workflow. First, ensure Cypress is added to your project as a dev dependency. This can be achieved by running the command npm install cypress save dev. Then, add a new script in your package, JSON file for running Cypress. It may look something like this: Cypress run. To integrate with your CI/CD pipeline, you would need to add a new step in your pipeline configuration file that invokes the Cypress run command. This could be something like run npm run cypress run. If your CI/CD pipeline is configured correctly, Cypress tests should now run automatically every time changes are committed to your code or a pull request is created. The success of your pipeline now depends on the success of your Cypress tests, ensuring that your application is always in a releasable state. 22. What challenges have you faced while using Cypress, and how did you overcome them? While utilizing Cypress for end-to-end testing, I faced several challenges. One of the major challenges was with handling iframes due to Cypress's restriction on browsing through different origins. To overcome this, I used a workaround where I fetched the iframe's body using the sci/wrap method. Another issue was the inability to work with multiple tabs or windows, as Cypress supports only single tab testing. I mitigated this by redesigning the tests to function within a single tab and focusing on the application's state rather than browser behavior. Dealing with complex animations was also a hurdle, as Cypress might attempt to interact with elements before they're ready. I managed this by increasing the timeout duration for certain commands in my test cases. Lastly, Cypress does not support native mobile applications or browsers other than Chrome and Electron, which can be a limitation in certain testing scenarios. I addressed this by combining Cypress with other tools where necessary, to ensure comprehensive test coverage. 23. Can you explain how to use assertions in Cypress effectively? Assertions in Cypress play an essential role as they are used for validating if the state of your application conforms to expected conditions. They are the checkpoints that confirm whether the actual output matches the expected output. Assertions can be added by using the should or and commands, followed by the condition to be asserted. For example, the command sci.get, example, should have class active, is an assertion that checks if the element with class, example, has an active class. If the assertion fails, the test will stop, and an error will be displayed. Remember to make your assertions as specific as possible to ensure your tests are robust and less prone to false positives. Also, make use of Cypress's automatic retries for assertions to handle asynchronous operations. Cypress provides a rich set of assertions that can be used effectively by understanding the application's requirements. For example, to confirm that an element exists on a page, we can use the exist assertion. If we want to confirm that a particular text is present in an element, we can use the content assertion. We can chain multiple assertions to make our tests more robust and reliable. It's also important to understand the difference between implicit and explicit assertions, which can help in writing more efficient tests. For instance, an explicit assertion would be where we explicitly define what we expect, while implicit assertions are those that Cypress does internally. In terms of best practices, always remember to make your assertions as specific as possible, and use assertions generously throughout your tests to ensure each step is working as expected. 24. What are some limitations of using Cypress compared to other frameworks? Cypress is an excellent tool for testing, but it does have some limitations. For instance, it only supports JavaScript, which may be a restriction for teams that use other programming languages. It does not support multi-tab testing, a feature that many other frameworks offer. If a test needs to switch between tabs within the same browser session, it may not be possible with Cypress. Another significant limitation is its inability to handle multiple browser instances, limiting the opportunity for simultaneous testing. It also lacks support for native mobile application testing, which many modern testing frameworks offer. While Cypress offers real-time reloads, the feature can be a bit buggy at times. It often requires manual test reruns, which can affect productivity. Despite these limitations, Cypress remains a popular choice for its easy setup, great debugging capabilities, and real-time test running. 25. How do you handle file uploads in your tests using Cypress? To handle file uploads in Cypress, we first need to read the file we want to upload. We can use the fixture, filepath, binary method to do this, where filepath is the path to the file in our fixtures folder. This method reads the file and returns its contents in binary format. Next, we convert the binary data to a blob using the Cypress blob base64 string to blob function. This function takes two parameters, the binary data and the MIME type of the file, and returns a blob. After that, we create a file input event and trigger it on our file input element. We use the sci.get selector, trigger, event name, options method for this, where selector is the selector for our file input element, event name is input or change, and options is an object that includes the file blob and other properties like the file name and type. Note that this method of handling file uploads only works if the file input element is visible. If it is not visible, we have to make it visible first before triggering the event. In wrapping up, we hope that our list of the top 25 Cypress interview questions and answers has been helpful in your preparation. We've aimed to cover a broad spectrum of topics to provide a comprehensive understanding of what you might encounter in a typical Cypress interview. Remember, aside from the technical knowledge, your problem-solving skills, attitude, and communication abilities also play a significant role. So, make sure you are well prepared. If you found this video useful, please show your support by giving it a thumbs up, and don't forget to subscribe for more useful content like this. Best of luck with your interview.